Testing, testing. Okay. So today I wanted to do a short stream to sum up the Windows port that I did over the last couple of days. And just to recap what I'm trying to do, I have a game that I program on OpenBSD, sometimes on Linux, but mostly OpenBSD, which means it uses OpenGL and all the POSIX APIs and on OpenBSD it's the sound IO interface for sound. On Linux that's Pulse Audio, and it uses controller input using the HID interface on OpenBSD and the iOctl system on Linux. and to open Windows, I'm not talking about Microsoft Windows, but normal Windows, it uses X11 on both Linux and OpenBSD, and that works fine. I have had some doubts about the direction the game is heading in, and just to give myself more time to think about that, I started with the Windows port, which is a fixed requirement, so that had to be done anyway, and I started with that. So the game was running on OpenBSD and on Linux just fine, and I always wanted to use cross compilation to handle Windows. So the first thing I did was I installed Windows, of course. I bought a cheap hard drive, put that into my PC, and installed Windows 11. Then I installed the Windows subsystem for Linux, which I can open here. And then I downloaded all my code. I installed, so this is the subsystem for Linux, the Arch Linux variant, just because I used Arch for the proper Linux port, and I'm quite familiar with it now. I installed just a few things. That's LLVM, which brings Clang with it, and Tmux, VI, etc. But nothing fancy, just the compiler and editing tools. And I downloaded the code, which lives right here. Let me clean this. So this is the code. And because this is quite a big task, I started by just opening a Windows window, which means I didn't use any of the code I had. I made a new file, don't know what I called it. I think I called it main.c, and made it open a window. using cross compilation. So the thing is, for everything Windows, you have to include the windows.h header, which does not come by default on Windows subsystem. So to even start this, I had to gather all the SDK headers for Windows that I needed and the base libraries that you always need to have, which are libcmt.lib and kernel and user and some others. I'll show that later. And how I did that is I used xwin. That's a program called xwin that's on GitHub that you can use to download all the SDK files. And then I started by including the windows.h in the main.c file and just ran it with the compiler. And then the compiler would say, okay, this .h file is included in Windows, but it's not found. Then I would go find that file in the SDK folder and copy it manually in this W32 folder, which I have in my code now. And I did that as many times as I needed until all the headers were found. So if I look in this directory, there's a lot in there. But that took about 2 hours or something and was relatively painless. As you can see, I also have libraries in this folder. Some of these are required. Some of these are required, like the input, because for other functionality. So for the controller input, I needed this library. And so I pulled that from the SDK folder as well. But that was later on. The first task was just opening up the window. And I used the Kronos OpenGL context tutorial for Windows. I'm not sure if I can find that. Kronos OpenGL context 32. Is it this? Yes. This is it. I started with this code, which uses this windows.h, which you need. And it includes the gl.h header, which I have already from OpenBSD and Linux, which just has the function definitions, which are the same. And yeah, so you have this winmain entry point, and you have to set up a class and create the window. So I just used this code kind of as is. And then you have this window proc, which you register, which is really similar to X11, just the event handler. And then finally I had Windows open a window for me. A huge pain was opening exe files from the Windows subsystem, because that was just an ls, was it? Yeah. Because I can, with this command, just open any exe from the subsystem, but it does some kind of, sometimes I couldn't figure it out, but sometimes it would buffer the exe file, and I would sit there literally for hours wondering why my changes wouldn't work. And it was because it always opened an old version of the exe file. So that was the first real pain. But yeah, once I figured that out, it was pretty simple. So the compiler I used for most of the time was ClangCL, and that is a drop-in replacement for the Windows CL compiler. And my understanding now is that it's just calling Clang under the hood, but you can put in MSVC specific options here. So if you know Clang or GCC, you would, to generate debug information, you would type -g. But on Windows, the same command would be /CI or C7, or one of those. And ClangCL translates the Windows commands to something Clang understands. That's my understanding right now. So I use ClangCL with the Windows flags, and that worked. But in the end, I just used Clang as is with a target flag. So if I show the make file, well, I can just explain this fully. So I have this flag that I set for which operating system I want to compile for. And things I skip are not important. So I have this sources list of sources that are platform independent. And I have some flags for the compiler to help me catch errors. Then I have here the architecture GNU. GNU is just a name I gave it. And it has a output name. It uses GCC. It has GCC flags, as you would expect. It has include flags, which is libmath, x11lib, libx input, then pulse audio and pthread. And then it adds to the sources platform-specific files, which are just what you'd expect. And this is some macro magic to turn these source files into object files just by name for the compiler later. Same thing for OpenBSD. It's actually almost the same as the Linux target, just that the libraries are a bit different. And then when I come to Windows, the output is a .exe file. I'm using Clang. I'm using LLD as the linker, which is required for some reason. because LLD understands how the Windows ABI works. Then I have more C flags for Windows stuff that mostly just mutes dumb error messages, but also alerts me to the long problem, which is that on Windows, int long or unsigned int long is always 32 bits. On POSIX, well, I'm not sure if it's a POSIX thing, but on BSD and Linux it is unsigned int long is 64 bits. So you have to use long in your code to cover all the operating systems. And these are just some flags to catch that. So this is the meat of the sauce. I add the target Windows PC Windows MSVC to Clang, and I import the header files in my folder where I put them, not with capital I, but with iSystem. For, don't ask me, it's complicated and I don't understand it, but this works. So I have to tell Clang, oh, I'm sorry, I'm not sure what Windows is doing here. I have to use this, I have to tell it to use the LLD linker explicitly. And then, well, this is also fun. So if you don't know, Windows has, if you open up Visual Studio, it asks you if you want to create a console application or a Windows application. And think of a console application as what you get when you compile a program on Linux or BSD. And the Windows application just strips away the standard input and output. And that's what I want. I want a Windows application because if I use the subsystem console, if I run the app, it will always open a console window in addition to the window that I open. So I use subsystem Windows, which does away with the console window. But the problem then is that it expects a win main entry point. But I of course have my entry point in my project named main, like everybody else in the world. But this subsystem Windows expects a win main entry point, which you can then suppress with entry main CRT startup. So if you add this, it uses the normal main function. And how this works is the same on all the operating systems now. For my app, it goes into main, it initializes its systems, and then it calls open window. Open window is different depending on the platform, but it's just the normal open Windows code that you find here. it's exactly this. It's just not using winmain. This is in my open windows function, open window function. So it just works. There's no, it doesn't complain that I open the window not in the main entry point function or elsewhere. That just works. So I don't have a winmain, I just have a main function, and Windows is treated just as the other operating systems are, which is opening a window is just it's just that. And yeah, one important thing is the polling of the events, which I'll touch on in just a minute. Then I have this ignore for. This is, I think, not sure why I have this, but I'm pretty sure it's needed because of the header files, because the header files are stupid or something. The Windows header files. Not exactly sure, but I think that's what it is. And then I give it the library include path also for the folder. And then the libraries I include are libcmt, which is the most basic thing that you need for mounting the C runtime. I think this is the C runtime. Then I have the kernel, which is also needed for stuff. User GDI is needed for opening the OpenGL context. Then I have direct input for the controller, and I have WinMM for the audio. And those are reflected in the source files that are specific to Windows. And that's basically it. And this is the compilation. This is a BSD make file, so don't copy this verbatim. This won't work on GNU make. But yeah, it just compiles it, and that's it. So let's look at the, let me close this. Let's look at the event loop. Not L. Yeah, so this is the code. Open window. It does what you'd expect it to do. That is just the Kronos code, a bit reformatted. And then, yeah, I do initialize WGL. This is pretty similar. Let me make this so I have all the files. So I don't link, as you've seen in the makefile, I don't link with the OpenGL library. I load it at startup dynamically. And this is done right here. So I load library OpenGL, and this looks almost exactly the same on all operating systems. The only difference is that on Linux and BSD, you use the glx library to initialize the context, if I'm not completely mistaken, but yeah. So on Windows, you load the library, and then I have all these function pointers that I set up here, somewhere up here. Yeah, here. Oh, not sure why it does the visual bell. Actually, let me enter tmux. Then that's gone. Where was I? WGL. Yeah, so you load the library, you hook up all the function pointers using getproc address, but that is only for the, well, Windows calls it extensions, which is, I mean, so getproc address works for everything under, I think it's OpenGL 1 point something. All the functions in the oldest OpenGL implementation. So everything above that needs another getproc address, which is WGL getproc address, which I itself getproc address somewhere here. Hello. Oh yeah, here. Okay. So with enough function pointers, I can create the context which is needed for all the other function pointers. But first I check the version of the OpenGL implementation. If it's too low, then I'll just crash. And then I enable vsync. If vsync is not available, I'll also crash, because yeah, the picture is horrible. I tested this without vsync and it really makes you sick. It's all wobbly. And then I get all the other functions I need. So this is version 1.0, which I get with the VGL getproc address. And that goes on up until 2.1, which is what I target. And I get also check for the frame buffer extension, which I use for FXAA. Yeah, but that's not important right now. So that's how I load OpenGL. It's also important to note that the swap buffers function differs from BSD and Linux. So that's, I had to move that out. Okay, back to win.c. Now I have a OpenGL context, and this is for the gamepad that I'll touch on in a second. So every frame on all the operating systems, I call this pull event function, which does basically the same on all of them, which is mainly get a window close message if the window is closed with the X in the corner, and terminate the program if it is received. Then just keep the event loop running with these messages: translate message, dispatch message. There are equivalents on the other two operating systems. and keyboard input. So keyboard input I handle in these event loops. They are, I think they are the same on Linux and BSD. And it's pretty similar here on Windows. So important to note here is that I use peak message. If you have seen here, it uses get message, which is blocking. So you need something that's not blocking, which is peak message, and then you just, if it's a quit message, then pass that on. Otherwise, just do what needs to be done. The actual keyboard catching of the keyboard keys is done in the winproc function, which gets create window. See here. Oh, it's here. So it's in the window description. You add this event handler function, event handler callback, which is exactly this, which also has the quit message, and then it has key down and key up, which is the most important to me. What this does is it calls the scan code to key code function I wrote with the scan code, and it translates it to my internal keys. I had to revamp this because the key defines that I had, which are in the instruct. Yeah, so these are actually, let's make this full screen. So I have these key defines, and I stole these from GLFW because they had the idea to make their internal key codes align with ASCII, which is pretty neat. So these are all the keys that I need, and then some, and they all reside in this KS function array, their state, that is. So these are internal. The ones Windows uses are different, and the ones that BSD uses are different, and I think Linux and BSD are the same again. But yeah, I to get the proper key input, I need to translate this, which I did in this function. So this is just what you expect it to be. It gets an int, returns an int, and it translates it. Nothing more to it. So I have keys working now. This is an internal function of me that just sets this key on or off. And then I have this device change for the gamepads. So on Linux, I have not implemented this on BSD, but on Linux you can create an iNotify handler where you get a message if a new device is connected. On Windows, this comes with the window events. But you still have to register for it. So that's what happens down here. After the OpenGL initialization, I register the notification for device changes. So if you unplug the controller or plug in a controller, this triggers and calls and lands here. And here I can call my functions gamepad connected or gamepad disconnected. So yeah, that's about all that happens in the window creation. What else is what's also in here in this file are all the functions that I use that are in the standard library on BSD and Linux, but are not on Windows. So, for example, I have getopt, which passes command line arguments. That is taken straight from the OpenBSD source. Then I have string separation, same thing. B0, well, I wrote that myself because that's easy. And I have these warn and error functions that are on the POSIX operating systems, but not on Windows. String L copy, also not on Windows. And yeah, then I have other operating system dependent code here, which is for example, give me these seconds since program start, which uses query performance counter on Windows, but uses clock get time on POSIX. And yeah, more of this stuff. Strillcat, and what is this? This is a string case compare, and yeah, that's everything basically that I used that was not available on Windows. I just pulled in the code. Yeah, because these are small self-contained functions, so that's easily done. Let's look at this real quick. Yeah, so I looked at the STL2 and GLFW libraries for the game input, because it's just a whole bunch of black magic. If you look at this, I have no clue what this does. This just yeah, no idea. But it's needed for the device notification. So yeah, in every file, so this is a win.c. This is only built on Windows, so it's relatively simple. There's this Windows 32 lean and mean flag that you can set before importing Windows.h, which removes the need of having, I think it's only 20 or 50. Well, it's not 50, it's only about 20 headers that you don't need to have if you use this flag. And then some other headers for the direct input stuff. So yeah, so now we have a open window, we have a OpenGL context, we have key input. The next thing was, actually I might need to, so this flag is pretty important. Let's just touch on that. In the tutorial, it only has this CSOwn DC flag set here, but you need the H redraw and V redraw flags, or else your program renders, but it only renders when you move the mouse, so which is pretty baffling if you see it the first time. So yeah, it's just these two flags. And also create window, if you use a WS pop-up, it's a borderless window. Yeah. So that's the everything before the special stuff. So the next thing I did was the controller input. I had the notification here is I added this at the end. So this is late game. The actual controller code I put into direct input.c, and it imports direct input as you would guess, and then it has, I created these, well, yeah, it's ugly. You need, so how it works is that, well, let me take a step back. First of all, I used direct input because it does everything I need it to, and the other APIs are too specialized. There's the X input API on Windows that only works with Windows controllers or something, which is stupid. Then there's the Steam input library, which is just yeah, it's a Steam thing, but I don't want a Steam thing, I want a Windows thing. And direct input does everything, but it's ugly. So when you say, hey, give me the connected devices, it gives you, you pass in a callback, and then it enumerates all the devices. So you have one callback for every device, and then for every device object, that's what they call it. A device object is things like, yeah, as I wrote here, axis, button, or slider. So a device is a gamepad, and a device object is an input on the gamepad. So you have two callbacks that get enumerated, and so you need these structs to hold on to the data. And then I have the real gamepad struct, which I have for the other two operating systems as well, but they look a bit different. You have the GUID, which I need for the STL controller database, they call it. It's just a header file where the GUIDs are mapped to actual controller input mappings. So if I plug in a PlayStation controller, it works out of the box with all the buttons correctly mapped, the same as when I plug in a Xbox controller. That's done with the STL controller database. For that I need the GUID, which is generated as STL tells you to generate it. So that's not something that comes from the operating system. That's something you build yourself. And then I have objects. Of course, it's just stuff. This just housekeeping stuff. And then I have an array of objects, and the device. I have the index of the gamepad, but I really actually don't need that. Not sure why that's there. And then I have the on flag, which is from me, just to say, is it connected or not? And these two are mapping arrays for the STL controller database. it's quite ugly, but it works. So then I pulled in this whole piece of something from GLFW and STL2. They both have these, and GLFW even says thanks for STL2, thanks to STL2 for mapping this whole stuff. I've actually no idea what it does, and I'd rather not know. So there's this data format, and let me go down here. Where's the entry point? So initialize gamepad, which is actually badly named. It should be named here, initialize direct input. So you get a handle, you create an instance of the library for whatever reason, and then you start enumerating devices, and you pass in your callback, which is dvenum for me, and this then begins here. Setup code, setup code, setup code, setup code. And you get the capabilities, and then yeah, you set the access mode. And this is mostly from, this code is mostly from GLFW. And then you have to sort the objects. Well, actually, yeah, this is the enum objects. This is the other callback. And then you have to sort these to get it in line with the STL2 database. And here I then create the gamepad. And here I generate the GUID. Yeah, I get the product name. And then you have to have this UTF-8 encode function that you have to, well, it's homebrew in STL. I just wrote it myself. Well, actually, I'm not sure where I got the code from. I'll have to look at that. But yeah, you do the STL thing of creating the GUID. This is the same on all operating systems, or kind of at least. And then, yeah, this is the meat of the STL controller database mapping. This past GPMP is, he looks up in the database. I can show you the database. It's gamepad.h. So that's all it is. It's a array of strings, and there's one for Linux and there's one for Windows. And one, there's none for BSD. So I didn't care to implement this on BSD. So yeah, what this does is pass GPMP. It's just, it looks for the GUID in these, at the start of these entries, finds the correct one, and passes it into a mapping struct. And then for all the objects in the gamepad, if it's a button, then I map the mapping button. Actually, it's, yeah, the mapping button to the button, and the same with the axis. I just map the mapping to the axis. That will make sense in a bit. But that's basically just assigning one mapping to one input, because the order of them is essential. And yeah, let's look at the map object. So for every input feature of the gamepad, device object of a gamepad, again, an axis or a button, it sets some properties just to have an even playing field between the inputs, and assigns the type. And yeah, it sorts out stuff it can't use. The same for the buttons, and for the POV are the head switches. They're called head everywhere else. On Windows it's POV. Yeah, that's basically it. Let's look up further. Okay, this is the whole gamepad function that's called every frame. Get device stage here. It looks if it's still there. If not, then it bails out. And then for all the objects in the gamepad, this is actually really similar to the code on Linux. Well, except for this, which is, yeah, just insanity. It gets the value, the float value of the axis or slider. I think slider are the trigger buttons. It gets the float value, and then it does the scaling as prescribed in the STL database. And then this is then simply my code. It turns buttons, or it turns the triggers on and off depending on the threshold, and same for the analog sticks. And then for the buttons, it's pretty much the same. If the button's not null, then turn it on, and else turn it off. And the head switches, I've just hard-coded what they do. If you press right, then the D-pad east is on and west is off. And if there's nothing pressed, everything is off. That's basically it. Yeah, then there's close gamepad, does what you think it does. And this is the encode function. Looking if I'm missing something, but oh yeah, if I get the WM device change message from the window, I just enumerate all the devices again, and if I get a disconnect message and the device is gone, then I close it. So yeah, and what makes this somehow easier is that I only ever have one gamepad. And so yeah, that makes this a lot easier. So yeah, in the game, I call this init gamepad, I think, pretty much at the beginning. No. Oh yeah, here in the input function. Initialize input, and then I call the init gamepad, which does something different depending on the operating system. And that switching is just done by compiling one file or the other, but not never both. While I'm here, I can also show how I include all the files. So what I did, which is probably not the cleanest solution, but I just went through all files, put all the headers that are not in Windows into this if not defined, and all the headers that Windows needs but nobody else in an ifdef. And that's it. That's how I handle the includes. I could probably put the logic in here, maybe, I'm not sure, but I need to, yeah, whatever, it works. So what's left is just the audio. Compilation, what do I say? Yeah, and then some words on the compilation. The audio, I looked at all the options for the audio APIs and I needed the simplest one. I needed one that's very close to what I think is the absolute best model, which is the Sound.io library on OpenBSD, which is so simple. It's still astonishing to me. So I needed something that is I had the approach on Linux and BSD is you spin up a thread. That thread initializes all the audio and then does nothing but write to the audio buffer of the operating system until it's called to stop and close. And in this loop, in this audio thread, it calls a render audio, which renders the audio. So it's a pull model, as you might be familiar with. On macOS, it's the same, I think. So you're not pushing the data into the audio subsystem, but the audio subsystem pulls the data out of your app. So I absolutely wanted to have that. So that was a strict requirement. And the API I settled on is the WinMM API, which is really old. And apparently, but I'm not even sure what that means. I've read that it's software emulated, but it's all just software. Okay, who cares? It works. Let me look at the file. Yeah, so of course Windows doesn't have POSIX threads, but the Windows API for creating threads is actually pretty easy. So I use atomic init as on the other operating systems to initialize a integer that I use as a, what's it called, a semaphore? Well, not really, it's just a flag if the thread should close or not. I create the thread with my thread function, and apparently you have to tell Windows that this is actually not, yeah, it's that you're not playing games, but that this is actually something that you want to run. So the thread does nothing but initialize the audio subsystem, which is done by filling out this stuff. Yeah, so this is the main thing. This format, wave format, ex file struct. And I just say I need 2 channels, 44.1 kilohertz, 16-bit, and then these. I mean, block align and average bytes per second. These are just, it feels like making your taxes, but I think this is the same on the other operating systems, so must have some meaning. And then this is the thing. So this WinMM API has a couple of modes it works in. There's the callback AI, not AI, the callback. Is it an API? Maybe. So it works with callbacks, which means you start this off. It doesn't block. You just say, okay, here's my callback, and then the operating system calls in every time it needs the buffer filled. But you have no idea what kind of thread this is coming on, so you can't really do anything in the callback. The other variant I've forgotten, but the third one is you can tell it to set an event when it needs data, and you can abuse that to create something like what I want. So I create this dummy event, and then I call the actual API function. This is the most important function here. And I tell it the format. I give it the event, and I say callback event. So it will call on the event. And the other important piece is here. Wait for single object. Let me show you. How this works in OpenBSD. Oh, come on. Okay. So this is the OpenBSD thread. It does some stuff. Same thing here. 2 channels, 64-bit. Then set some parameters and get some parameters. Oh yeah, this is set this stuff and look if it sticked. If not, I just crash. Yeah. So, but it might be that these rates are not available. So you have to do that. And then you call start. And this is the brilliance of their API. I render the sound, and then I call SIO write. Ignore this check. I just call this and it blocks. So I can have the audio thread in a while loop. So this is just a thread as on Windows. that's just two functions, and it works. So this IO, SIO writes the data to the operating system, and it only returns when it needs new data. So yeah, that's just, and I wanted this model. And here I have something similar. I write out the stuff, I render the sound here. I write out the data to the operating system. And then I call wait for single object, which is my event. This is blocking. So what is one function on OpenBSD is two on Windows. But it amounts to the same thing. This thread can be blocked here for as long as it wants. It just goes to sleep. And it wakes up, it renders sound, it writes it out, and that's it. So that's the best I could do for audio. And this render sound function does just all the game stuff. So it takes in all the game's data, the game state, and spits out a block size of audio samples. Yeah. And with this API, you have to deliver the data in blocks, which I haven't quite grasped the meaning of yet, but I just use 2 blocks. One for rendering and one for writing. Actually, not sure if that's needed, but yeah, it's just, it works. So yeah, that's read sound. Okay. Actually, I'm not quite sure if I need this. It should be called read wave file. But anyway. So yeah, after that, I had everything working. I'm trying to remember what the bugs were. Oh yeah, a huge problem. Maybe the biggest problem was the random number generator. I mean, it had its problems anyway, but using the query performance counter or something, I think it also was the long problem, but the randomness was completely different on Windows and much worse. So I had to rewrite all the random number generators. I can show them to you actually. They are in utils. Where are the most important ones? Yeah. So I now have this random unsigned int function as the core. Before that, I actually had a double as the core of the randomness functions, which returned a random number from 0 to 1, which is totally fine, but not if you're working with seeds. So I have this random unsigned int seeded, which uses the app seed, which is set at program start. And I have the non-seeded version that gets its seed from from a timer. And on POSIX, that is clock get time. Yeah, so pretty similar. So, but that's not that important because it's the unseeded randomness that can deviate from operating system to operating system, but not the signed ones. So now I have more deterministic base using integers. And then I have this Stack Overflow Frankenstein that makes the so if I want a range of, if I want a random number in a range, say give me a random number from 0 to 9, then using the modulo operator down here skews the distribution, and this makes it more uniform. That's another huge change. And then the random float is much simpler now. I just get a random unsigned int and divide it by a double of int uint max. And yeah, so these four are the main functions that I use in the game. That's a random integer signed, and they all have min and max. Yeah, so this uses these two use the range one, and the floating point variants also use min and max values. Like this, yeah. So this is much more solid now. Other problems. Well, so in general, the Windows subsystem for Linux is it's super slow. So, and I'm talking about the terminal. The input latency is it's atrocious. It's absolutely horrible. It gets even worse when you use tmux. Okay, I'm using tmux already, but it's really, it feels like tar. So would not recommend. I have looked at Alacrity, which seems very performant, but has a batshit insane configuration system, which is just on Windows at least makes it uses config files, but in weird locations, and you have to open Notepad in administrator mode, and it's absolutely insane. So Windows Terminal is what you have to use, I think. There are bugs, as I said at the beginning, with the buffering of the .exe files, which is inexplicable. But it does work. It does work. As you've seen, I compiled the game with Clang. and I get an exe file, and I can run that, and it works. I noticed that it is much slower than on Unix. Not sure why. I may be able to get behind that, but yeah, it works. Oh, and also, yeah, so I spent almost a complete day trying to find a good debugger. I tried Visual Studio and WinDebug. They're both incapable of debugging an exe file that lies in between all its source files. They're just not able to connect the debug symbols. Not sure why, because LLDB came to the rescue and could just do that without even asking. So I'm not sure if, I mean, WinDebug should be able to just debug any exe file. But then also let me show you. So this is just completely arcane. You can open, oops, not that. You can open your exe and you can run it, but yeah, I mean, it doesn't do anything. This is the most atrocious thing. This made me quit this app eventually. You click on a stack and it scrolls all the way to the right. It's just inexcusable. And it does that every time. So you can open source files here, but I mean, it just doesn't work. And you have this command line with arcane syntax. And I just don't get it. Then you have Visual Studio, which I also installed. And then if you open the app in a folder, well, this is actually not the folder I had. I had all the source files in here, but I threw that away. Eventually, I don't want. So you can set this as, I mean, I'm sure I'm doing something wrong, but I've been doing this for a long time, and I can't explain why this is not intuitive. So this works, but you cannot set a breakpoint in a source file that it does not break in itself. So I had a assertion that sprung, and it showed me the assertion, the source file, the line of code, but it would not allow me to open another source file and set a breakpoint there to check what the error was. So I tried everything. I just couldn't get it to work. Then as a last resort, because I was also confused by LLVM and all the different versions, but I finally thankfully installed LLVM. I downloaded the installer from the web, installed LLDB, and I can now easily call LLDB, and that is the exe version to debug Windows executables. And it just works. It's a dream. So yeah, I solved that problem after half a day of needing a debugger because the game crashed and I couldn't tell why. But yeah, LLDB came to the rescue, which is actually great because that's one less thing you have to install, because the Visual Studio installation is at least 5 gigabytes. And WinDebug, not even sure, but that can go. So yeah, that's what I did in the last week. I ported the game. I am still kind of struggling with where the game is headed and if it's the right thing, but I have a path forward. And I'm still on track with the timetable. So no worries there. But yeah, I think I'll have more non-programming streams coming. And also one big problem with the current, path generation is that it just doesn't find enough paths. I have this, so the random number generator is much better now, much less biased, but it still only finds, I think, 20 different paths. So I'll have to get into that pretty soon. So that's actually a programming stream. Okay. So I think I have... So I wanted to make this stream today before I forgot about all the Windows stuff I did. And it says something about the dev env setup. So hardware. So yeah, the setup really just was WSL with Arch Linux and LLVM. That's it, and rsync to get my files. Okay. Hope this was helpful to someone, and I will see you in the next one. Bye.